Okay, so starting with today's warm-up, it wants to know what is the least common denominator. I want to make the denominators the same. So what I'm going to do is I'm going to multiply this first one by a 3 to make it 12. And I'm going to multiply this one by a 4 to make it 12. Now the denominators are the same. Now, if I multiply the bottom by 3, I also need to multiply the top by 3. So 3 times 3 will give me 9. Since I multiplied this denominator by a 4, I also need to multiply the top by 4. So this would become 8. So now I have two fractions where the denominators are the same. Let's try number 2. I want the common denominator and I want the least number that it can be, the smallest number that it could become. So what do you think I should multiply these by? What do you guys want the denominator to be? 18. I want them both to be 18. So in order to do that, I need to multiply this 6 by 3. So I'm going to multiply both the numerator and the denominator by 3. 5 times 3 is 15. 6 times 3 gives me that 18. What do I need to multiply this fraction by? 2's. Both the numerator and the denominator by 2. 7 times 2 is 14. 9 times 2 is 18. So now I have fractions that have the same denominator. Okay, so we learned this way back in elementary school. We have to remember, in order to add fractions, the denominators must be the same. If I want to add or subtract fractions, the denominators have to match. Okay, now that they are common, they match, I can add these together. The denominator would stay the same. 9 plus 8 is 17. The denominator stays the same. 15 plus 14 is 29. Okay, we're going to take this same thing that we learned a long time ago and apply it to algebra 2. Okay, so let's look at the first example in the notes. We're going to be adding rationals. Okay, rationals are just more advanced fractions. Guys, are the denominators the same? Do they match? Perfect. Keep it the same. Copy it down again. Keep it the same. And then you just add the numerators. 2 plus x is just 2 plus x. They do not combine. That's the answer. Next. Are the denominators the same? Perfect. So we're going to keep them the same. I'm just going to copy down the denominator again. Whenever you have the same denominator, you can add the numerators together. So I have an x squared. So I'm just going to write x squared. I have a 3x plus a 4x. 3x plus 4x is 7x. And then I have negative 2 plus 12. That is 10. Okay, so the last thing we're going to do is we're going to factor and simplify, if it's possible. I can factor the numerator. So I'm going to do an eye chart. I want two numbers that multiply to 10, but add to 7. Good. 5 times 2 is 10. 5 plus 2 is 7. So I'm going to rewrite the numerator as x plus 5 times x plus 2. The denominator will just stay the same. So I'm going to copy it down. How can I simplify this? Good. I'm going to cancel out x plus 5. That matches and that matches. So this is my final answer. So when I add these two rationals together, this plus this equals this. X plus 2 over x minus 2. Next example. Are the denominators the same? Perfect. So just copy down the denominator. And we'll add the numerators. 3y plus 4y is 7y. 9d plus 7d is 16d. Next example. Are the denominators the same? Yep, same process. You can do example 4. Example 5, this is a trickier one. Let's look at it. Guys, if you can factor, try to factor, okay? Or if you can simplify, try to simplify. Let's look at this example. What can this and this both be divided by? 4. Whatever you divide by goes on the outside, remember? 4 divided by 4 cancels. I'm left with an x. What's 12 divided by 4? 3. Okay, so this is how we rewrote the denominator. We rewrote it, rewrite. Okay, so this is what the problem looks like now. I have 2 over, I rewrote the denominator to become 4 times x plus 3. And this one stayed the same. Okay, are my denominators the same? What's this one missing? A 4. So guys, I'm gonna put a 4 here. Now are they the same? Perfect. Let's also multiply this by 4. Whatever you do to the bottom, you must do to the top.
So we're not gonna do two.
Okay, so I'm gonna rewrite this. This will become, what's 4 times 7? 28, okay. So the denominator stays the same. What is 2 plus 28? 30. So that's how you add those fractions together. Those rationals together. Now, I don't want you to stop there. If you can simplify, always simplify. So the 30 can be divided by 2, and this 4 can be divided by 2. So if we simplify this, 30 divided by 2 is 15. 4 divided by 2 is 2. So we can simplify it to become this. Next example. Okay, are the denominators the same?
No.
No, we're gonna have to change it. So I'm gonna write this a little bit bigger. I need more space. Okay, I just wanted to write it big. Okay, guys, look how I'm gonna make the denominators the same. I'm just gonna put this x plus 3 here. What does this one need? A 10 and an x. Now do they match? Perfect. What you do to the bottom, you also need to do to the top. So I also need to put a 10x here. They have to match. Whatever you do to the bottom, you also do it to the top. So because I put a 10x here, I also need to put a 10x in the numerator. Because I put an x plus 3 down here, I also need to put an x plus 3 up here. Okay? All right. So let me write down what we have. Whenever you're adding fractions, you keep the denominator the same. So my denominator is just 10x, x plus 3. Okay, now let's combine the numerator. First, what's 7 times x? 7x. What's 7 times 3? 21. So I have 7x plus 21, that's this one, plus what's 10x times 14? 140x. Any questions until here? Okay, good. All right, now we're going to combine like terms. This is a 7x, and this over here is a 140x. We're going to combine those. So my final answer will be 147x plus 21 divided by 10x times x plus 3. Let's do this example. Let's look at the numbers first. This has a 4 in the denominator, and this has a 2. What do I need to do so that they're the same number? Yeah, multiply this by 2. If I multiply the bottom by 2, I also need to multiply the top by 2.
Did you divide?
Okay, so 2 times 2 will give me the 4 that I want. What is this one missing? An x. It's missing squared. So I'm gonna put another x here. And I need an x here. That's what each side is missing. Okay, so let's evaluate this. The numerator here is just 5x over 4. X and x is x squared. That's my first rational. Let's look at the second rational. 2 times x is 2x. 2 times -2 is -4. Now the denominator. 2 times 2 is 4, and then we have this x squared. Now the denominators match. So if I want to add them together, keep the denominator the same, and then add the numerator. 5x plus 2x is 7x, and then I have a -4. And that's your answer. Okay, so this example, what you need to do first, these denominators are not the same. So let's try to factor. You can do an eye chart. I need 2 numbers that multiply to -12, add to -4. That'll be -6 and 2, good. -6 times 2 is -12, -6 plus 2 is -4. So I'm gonna rewrite this whole problem. X minus 1 is on top, we didn't change it. But now we can factor the denominator. This is x minus 6 and x plus 2. And I'm gonna add this one over here. All right, guys, what is this one missing? What is this side missing? Good, it's missing an x plus 2. So what you're gonna do is just add it. Put an x plus 2 here. Okay, from here, you guys got it. The denominators now match. So you just copy it down. And you add the numerator. So I'll let you guys finish this. Okay, the numerator. 3 times x is 3x. 3 times 2 is 6. So you just add x plus 3x is 4x. -1 plus 6 is 5. So this is your final answer. Okay, let me explain this one more time. 3 times x is 3x. 3 times 2 is 6. So I'm going to combine this numerator and add it to this numerator. So x plus 3x is 4x. -1 plus 6 is 5. So that's how I got this.